Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. Thank you for joining us. I'm your host, Ben Crossman. Everyone out there, I hope that you're doing well. I hope that everything is going well for you and you are ready for some Computer America. So for anyone who's just tuning in and was wondering what the heck happened last week, well, here's the thing. We had some personal matters to take care of. Everything was taken care of. Everything went well. Hopefully you didn't miss us too much, but we are back live now Monday through Friday all this week with new live Computer America shows. And hey, for our first show back, we have a great program lined up for you where in the second part of the program, if we have time, we will be doing computer and technology news where we have tons of different articles and things like that. Everything that we that we may have missed, everything that we need to catch up on, computer and technology news. It's a great segment. But our first segment, and hey, we're going to give as much time as we need, and but this looks like a very interesting topic. We have none other than a company called Edgewater Wireless. That's right. We will be joined by the CEO of the company, Mr. Andrew Skafel. So if you if you don't know about Wi-Fi, this is going to be great because this is about technology that Wi-Fi has long been in for a bit of a shakeup. It's a very known technology. It's a very readily used technology. But hey, whenever you have improvements for something as basic as Wi-Fi, I think that turns a lot of heads. So everyone, let's go ahead and get started. But before we do, actually, computeramerica.com. That's where you'll find everything, including a link to our show notes that will have a link to our guest website, any videos, any articles, anything and everything that we talk about show here on today's program. You can find. Also, be sure to check out the live video portion. Of course, if you're listening to us on IRN, we thank you so much for tuning in. But hey, there's more ways to experience Computer America, including the video, the archives, the podcast, all that and more at computeramerica.com. So I think with that being said, let's go ahead, just introduce our guest and get things started here. And as I said before, Edgewater Wireless, if you haven't heard of them, well, they have been revolutionizing Wi-Fi infrastructure with over 20 patents, and they have the new Wi-Fi 3 technology and next generation access points. That's right, Wi-Fi 3 is the difference, delivering up to 50 greater throughput versus traditional Wi-Fi and dramatically lowering network infrastructure investment. Hey, who doesn't want that? So everyone, I want to welcome onto the show once again, Andrew, again, the CEO of the company. Andrew, how you doing? Welcome onto Computer America.
Excellent. Thanks for having me, Ben.
Our pleasure. So, I gave a little bit of a background on your technology and what you're working on there, but I would really like it if you could actually, kind of give us a bit of background on Edgewater. When was it started? And a bit of background on yourself. Have you always been in high tech, or is this something, kind of a new venture for you guys? What's the company's background? What's your background?
Ben, we're a spin-off from a military R&D company. And, at Edgewater Wireless, we make Wi-Fi better. As you mentioned, Wi-Fi has been around since 1999. And since 1999, it's followed the exact same approach. It's called a single-channel radio architecture. Now, at Edgewater Wireless, we're revolutionizing Wi-Fi with the industry's first multi-channel or multi-lane highway for Wi-Fi, what we call Wi-Fi spectrum slicing.
Mm-hmm.
It's geared. Sorry, go ahead, Ben.
Well, no, and of course we're going to kind of talk about exactly how that works and that kind of thing. But I guess a good way to kind of start off our conversation here is obviously Wi-Fi has made it everywhere. I mean, people will hunt for it. They will go to one store instead of another simply because there's a better Wi-Fi signal. I mean, it's really a lot of people's lifeline. But why do you think there hasn't? Well, I don't want to say there hasn't been investment in Wi-Fi because, I think we're up to 802.11 AC, AX, whatever the heck the current standard is. But I mean, dual channel and what we're working on. I mean, why do you think there hasn't been? Why hasn't dual channel and what you're working on been implemented 10 years ago, 5 years ago? Is this a matter of technology or just something that you've really created and you've created something truly new?
So we've created something that's truly new, and I think what you've really touched on is the phenomenal success of Wi-Fi. Right in 1999, I don't think anyone envisioned Wi-Fi to be absolutely everywhere. Mm-hmm. Right? Some studies have said that Wi-Fi is the biggest cause of conflict within the home. Right? when your Netflix gets pixelated or your video gaming experience gets all slow or laggy. That's really due to Wi-Fi, and a lot of that is due to the phenomenal number of devices that are on the network. It's like traffic congestion on a single lane road, and so a lot of the traditional approach to Wi-Fi just really hasn't taken that into account, and that's what we've done. That's really shaken things up.
And of course, we're going to talk about exactly how you do that. But a single lane road and that pixelation, I think everyone can immediately see why having more data throughput would certainly be a good thing. I guess the question is, and let's see, there's so many questions. Just why don't we go ahead and start with just dual channel Wi-Fi? And I'm sorry if I'm making you backtrack here a little bit, but I don't think we got your background. Have you been you've been working with this for a little while, but what's your background? I'm sorry.
So my background is I've been in tech about 20 years, and I've worked for some of the industry giants like Newbridge Networks, Alcatel, and some Silicon Valley based companies. Mm-hmm. And what really drew me to Edgewater Wireless was this really unique technology designed to address what is one of the most prolific challenges in the industry, right? This challenge of density or congestion, and so we've built a really great team here, and it's aligned with where the global Wi-Fi industry is going.
Right. And I'm just poking around here on your website. For anyone out there watching the video portion, we have your website up. But this particular part, and as I said before, we're not going to assume any kind of knowledge on the end of the listener. So let's start with something basic. And you have a nice article on your website about Wi-Fi spectrum slicing. And I think most people would be familiar with, the 2.4 gigahertz, which is, can receive interference from things like, a lot of other devices and even microwaves and things like that. It's a very congested, kind of spectrum that just standard Wi-Fi really uses. I think we recently moved to, and I'm sure that you could correct me here, but it's like the 5 gigahertz spectrum as well. That's it's something that a lot of dual band Wi-Fi routers will broadcast on as well. And it's a little bit less congested, but at the same time, it's there are its own limitations. So Wi-Fi spectrum slicing, why is it such a big deal? And just kind of what were you hoping to tackle with this? By, I guess you mentioned here that you can actually deliver more of these, kind of lanes or lanes for data.
That's right. That's right. So the traditional approach to Wi-Fi is confined to a single lane or a single channel. So taking your example of the 2.4 gigahertz spectrum, your typical radio can operate on one channel at a time. One of any number of the channels that are there. If you try to operate on more than one channel using a traditional radio, you create interference. So what we do is we've invented something called Wi-Fi spectrum slicing. So taking that scarce spectrum and slicing it up in a way that allows you to use more channels in a given coverage area. Right now we've got products that do up to 3 channels in 2.4 gigahertz and, 3 channels in 5 gigahertz. We're taking that all the way up to 9 channels in 5 gigahertz. Now, what does that mean? That means it's similar to a single lane road and a multi-lane highway. Mm-hmm. It allows you to remove the congestion or deal with that contention that is fundamental to getting better performance out of Wi-Fi.
Yeah, and by the way, I think when it comes to wireless technology, one of the new emerging things, because there's so much advertising going out about it. It's 5G wireless as opposed to 4G LTE. That's like cell phone signal and cell towers and things like that. And unfortunately, like that 5G connection, I guess, can get people confused with 5 gigahertz Wi-Fi. So Wi-Fi and cell, actually, that's something I should probably ask you. Obviously, your company works with Wi-Fi, and it's to really, make sure that Wi-Fi is as good as it can be. But a lot of people are getting excited for, cell towers, cell signal, and cell data, things like that. Do both technologies need to develop side by side? Does one kind of eclipse the other? I know that when people have a strong Wi-Fi connection, they err on the side of Wi-Fi because it doesn't count towards their data plan or things like that. But 5G, kind of what Edgewater Wireless is doing as opposed to cell signals, do both these technologies kind of develop, side by side?
That's right. I think you've hit on one of the key themes in the wireless industry. In our view, we see Wi-Fi as being complementary to 5G. That's you'll be using the cellular type infrastructure outdoors from big towers. Mm-hmm. And when you transition indoors, the robust low latency connection of Wi-Fi allows you to continue that same experience. And this approach or our work there has really been driven by our membership at the Wireless Broadband Alliance, so a major industry body as well. And this is really, one of the key takeaways I'd like to leave with people is, 5G and Wi-Fi are very complementary with one another.
Yeah, and certainly, and by the way, this for long-time listeners, they know I definitely do have fun talking about standards and things like that. We have things like we have the organization behind HDMI come on the show and tell us about the newest standard for HDMI, and it seems like the most boring thing in the world, but it really outlines what is possible in the coming years. And when you have a standard set in stone and you're ready to go, it really shows what technology will be capable of when that standard is fully implemented. So I love talking about standards, and hopefully here Wi-Fi 3, and when it becomes a standard, this is definitely very, very interesting. So tell us about, kind of this dual channel Wi-Fi, that kind of thing. Do you see it? Actually, I'm sorry. I just came up with the question I was going to ask you. For this change in technology, is this a need for more sensitive Wi-Fi, kind of Wi-Fi sensors and chips for technologies to use it? Or is this kind of a broadcasting thing where people's routers and essentially the sources of the signal are going to have to be upgraded? Or is this going to be a strictly, kind of like a software thing, and it's just going to be that? Like, what is the upgrade that is going to have to happen for Wi-Fi 3 and, this spectrum slicing to kind of happen? Is this going to be as new products roll out, or is this just going to happen overnight and people don't have to worry about it?
Well, this is something, just pulling on your thread about standards. We're really excited about standards as well. For us, it's a little bit of the technology visioning that gets done. And the commercial opportunity that it drives. Now, in terms of moving to Wi-Fi spectrum slicing, it's very much a hardware play. That's implemented on the silicon or the chip level. So it is, what we're talking about with Wi-Fi spectrum slicing and that ability to really efficiently use the scarce spectrum that's available does require a hardware upgrade. So, that's something that you'll start seeing. We like to see that, roll out in the enterprise space. We're currently deploying there, but moving into the residential space as early as next year.
Very, very cool. And of course, I'm pulling from your website again. The average user carries 3 to 4 different devices, all of which can connect to a network. And in a lot of ways, like, let's say if someone is tied into, a smartphone, a smartwatch, and maybe they have a tablet or a laptop that they carry, and so on and so forth. And there are devices coming out that are going to be, things like medical devices and eyewear that's going to be connected and require a lot of data. Do you think that something like what you're developing at Edgewater, do you think that something like what you're developing, can Wi-Fi really sustain itself if something doesn't change? Because we're asking more and more of a technology that really hasn't changed all that much in 20 years.
That's exactly it. There needs to be a fundamental change to the way Wi-Fi is delivered in order to support all of those latency-sensitive applications that you're talking about, right? Like, think of a medical device. You don't want your data getting bogged down or stuck in traffic. And it getting to the doctor slower than it needs to, or something that's a little bit more fun, like you're playing Fortnite and your connection gets laggy. Mm-hmm. So in order to do that, you really do have to take a step back and say, well, how do you equip a global industry so it can best deliver the service that people want? And that's really where Wi-Fi spectrum slicing comes in. Yeah. Now on top of Wi-Fi spectrum slicing, the emerging dual channel Wi-Fi standard also, it's really the first declaration by a global standards body, Cable Labs, that more than one channel is needed to deliver a high quality of service. So there's really some exciting changes taking place in the industry.
Yeah, and I wanted to see, and I think that all the technology that we're going to be talking about here today is going to play its role. But I wanted, kind of your feeling as to spectrum slicing versus something like, when we talk to companies such as Netgear or Linksys or whatever, when we talk to these companies, something that they're really adamant about that is going to improve performance is this idea of prioritizing, because the data that comes from, let's say, a laser printer is not going to be as time sensitive as Fortnite or something else, or maybe the input that you need for emails is not going to be similar to Netflix or something that you really need to prioritize buffering. Prioritizing the traffic seems to be the way that they're kind of handling this congestion at the moment. I'm guessing that will still apply when there's multiple lanes, except it would just be a little bit more complicated on the software side, that they'll have to allocate, okay, you go to lane or channel 1, 2, 3, 4, as opposed to just trying to triage data.
That's right. It's essentially, the current implementation of prioritization is trying to control the speed limit. It's like trying to control the speed limit on a single lane road on a per car basis, right, or per vehicle basis. It's pretty complicated to do that. Now, when you implement Wi-Fi spectrum slicing, if we look at what I have in my own house, right? We have flat screen TV that we stream to, right? That has its own dedicated channel. We have Wi-Fi IoT and a Wi-Fi security system. That's pretty low bandwidth things that maybe need more reach or more coverage.
Right.
So those devices have their own channel. So what Wi-Fi spectrum slicing does is create a powerful platform for all of these services to be taken up to the level that they need to be in this wireless environment that we're in.
So it's just one more essentially kind of lever to pull when you're trying to get that data to where it needs to go and how it needs to go. And by the way, I'm sorry, a great question from Nelson out there, and I really want to touch on this because we've recently, well, not recently, it's been a little while, but the last router that we reviewed was like the Nighthawk X10 from Netgear. Great router, and cool. But they have these things where they have different radios, and you can if it's a more crowded household, one of the key parts of a router that you may buy, the difference between a $50 router, $100, $200, and in this case like a $500 router, were the amount of radios that you have. 8x8, 2x2, 4x4. And people may see that and think that it's very, very similar or the same as to what we're talking about with the slicing that you're talking about. How is it different, or is it just a different implementation? If you could just explain how they would complement or overlap each other.
So what's typically being marketed on the side of the box, if you will, the consumer Wi-Fi products of 2x2, 4x4, or 8x8. Mm-hmm. That's actually in reference to the type of MIMO that's being implemented, and that's multiple input, multiple output. Mm. And what's being done there is they're taking a single channel, and they're either transmitting or receiving over multiple antennas, really to get better propagation is the theory behind that. Mm. Now, what many folks don't know, but realize once they've implemented this in their home, is each time you add an antenna, you have to cut the power in half. So the effective coverage area gets smaller and smaller and smaller each time there's an antenna added. So it becomes a real challenge to deliver performance to more devices that are maybe spread out through the home, or maybe not in the same room, a few meters or a couple of yards away from the access point. Now, what we're talking about with spectrum slicing is, rather than taking that one radio and dividing it up under multiple antennas, we can actually have multiple radios or multiple channels, physical channels in that given coverage area. And what that allows you to do is really optimize what's available. So does that make sense?
No, it makes perfect sense, and of course that's much more effective than running a completely separate I guess kind of internet line and setting up a second connection. It's you're just getting more out. It's as if you were adding more internet connections, but it's all through the same one, which is perfect. Although I will say you may have just solved a problem that I've been thinking about for quite a while, because here in the studio we're using that, and we're using all 8 radios. The 5G on this thing is actually very, very good when you're standing almost right on top of the router. But even when you put a single wall between 5G, between the 5G router and yourself, with 8 different radios, it's almost unusable. So I'm thinking that the signal just doesn't carry as far. And because 5G, and if you'd like to get into this whatsoever, 5G just because essentially the wavelength is so much more compact, it can carry a lot more data, but it's much more prone to interference due to walls and anything like that. So, anyways, it just seems like with 8 radios, 5G, even a single wall just made it very not good, I guess.
That's right, and that's really part and part.
Nope. You okay, Andrew? Oh, and I'm sorry, folks, real quick. Andrew accidentally, looks like we lost his audio there for just a moment. Hopefully he's working to get that back. He should be back in just a second. Everyone, Andrew Skafel, he is the CEO of the company Edgewater Wireless. If you haven't checked them out, edgewaterwireless.com. Definitely a very fun conversation, and we're just now getting into a separate topic. Hopefully, Andrew, kind of picks this back up here in just a moment. Everyone, again, thank you for tuning into Computer America. And by the way, Andrew, can you hear me now?
I can hear you now.
I can hear you now. And I'm sorry for kind of talking over you, but please go ahead and continue about the 5G and yeah.
So you've really hit on the fact that in the 5 gigahertz spectrum, propagation is very poor because of the physics behind it. Now, when you're adding more antennas to it, that propagation actually gets worse. Mm-hmm. So if you're running an 8x8 MIMO connection, it doesn't even have to be a wall. You could stand between the router and your laptop, and you can see the decline in this speed. So what we're talking about is really a fundamental change and like a fundamental innovation to address where Wi-Fi has really grown, and that's what Edgewater and Wi-Fi spectrum slicing do.
So we may be getting into, and by the way, Andrew, we're about to head up to a break in about 3 minutes. I'll interrupt you, and hopefully you can stay on the other side of the break, and we can continue our conversation. But I'm poking around here on your website, and this is the Wi-Fi 3 designation that you. And by the way, just real quick, Wi-Fi 3, is that something that you came up with, or is that an official standard, or Wi-Fi 3?
So Wi-Fi 3 was our brand, our initial brand, mm-hmm. Because it denoted 3 channels coming from a single radio. Now, recently, we've actually evolved our brand to better reflect what we do at the company, which is now expanded well beyond 3 channels. So we call it Wi-Fi spectrum slicing, because we can do more and more channels within that given area.
I gotcha. So, and sorry, I just saw the logo a couple places, and I was actually curious myself. But looking at some of the different features here, we've been talking about the multi-channel radio architecture, some of the other things, and admittedly, some of these will be more useful for businesses and things like that, which is great. I'm not knocking it at all. We're not just a consumer-oriented show, but you have one here, SSA, which, as you on your website, real-time integrated spectral surveillance architecture. I can see, and this is something that we didn't touch on, that when it comes to monitoring your connection, because for legal reasons, for productivity reasons, for security reasons, companies nowadays have to monitor their flow of information, where it's going, where it's coming from, who's accessing, that kind of thing. If you multiply that by 3, you would break a lot of the current solutions on the market that currently monitor data and make sure whoever's accessing or putting information in is who's supposed to be doing that. Do you have your own built-in kind of way to monitor traffic, or is that something that you're leaving to third-party companies to kind of figure it out themselves?
So we've built a at the core of what we do, it's actually a custom high performance chip or a Wi-Fi chip. Now, what we've done with it is we have left as much of it as open as possible, to allow vendors like a Netgear or Cisco to easily incorporate our chipsets and still take advantage of some of the work that they've done. Now, in addition to the basic sort of upstream features, the architecture of our chips allow, we use what's called a wideband radio. So we look at a large portion of the spectrum, and we allow that to be taken in and analyzed real time. So you can identify potential hackers or rogue devices on your network real time, or identify a source of interference like the microwave that you talked about earlier. That can all be done remotely in real time without interrupting your data flow.
And Andrew,
it's a pretty cool feature.
Yeah, definitely. And I'm going to stop right there. There's music playing in the background. I know that you can't hear it, but everyone else can. So everyone, we'll be right back. More Computer America, more Edgewater Wireless. Everyone, stay tuned. More Computer America right after the break. Everyone, we'll be right back.
Greece is cheap.
But the airfare costs a fortune.
Paris?
Not much closer, and again, airfare...
What about Puerto Vallarta?
Let's face it, flying anywhere is just too expensive.
Wait, what's this? Low-cost airlines.
With one call to low-cost airlines, you'll drastically slash your travel costs. We're talking insanely low airline prices to any of your favorite destinations. Where would you like to go? London, Rome, Costa Rica, Australia?
Wow, that's cheap.
So why wait? Call now to learn how crazy cheap it is to fly anywhere in the U.S. or international. Our prices are so low, we can't publish them. The only way to get them is to call to instantly hear the most amazing best deals on airline travel. It's that easy. So call now and start packing.
800-215-4461. 800-215-4461. 800-215-4461. That's 800-215-4461.
We are all Brother Wolf. 10 years ago, a group of locals banded together to create positive change. We took animals into our homes, held adoption events at local retailers, and talked to the community about our mission to help build a no-kill Asheville. A decade later, we have achieved so many victories for animals in need. There's been so much progress, yet there's still so much to do. As part of our year-long celebration, we encourage you to become a member of our special Compassionate Circle program. With a monthly donation of $10 or more, you will have behind-the-scenes access to the work we are doing at Brother Wolf. Our goal is to reach 1,000 members because we receive no government funding. Working together, we can help build and sustain no-kill communities. Learn more at compassionatecircle.bwar.org. We are a 501c3 tax-deductible organization.
And welcome back to the Computer America Show. It is 32 minutes past the hour. And by the way, ladies and gentlemen, if you miss any part of our conversation or you'd like to hear it again, hey, the podcast is what you want. It is today's live show, rebroadcast wherever podcasts are heard. Right there, very easy. Download it on any device. It's available through Apple Podcasts. It's available through Google Play. It's available through iHeartRadio, so on and so forth. Everyone go ahead, check us out. And like I said, it's going to be today's show again. But if you caught us live, don't worry about it. Thank you for tuning into IRN. And in the meantime, everyone, let's go ahead and continue on. Andrew's actually continuing on with us, which we definitely appreciate. Mr. Andrew Skafel, he is the CEO of Edgewater Wireless. And yeah, just before I kind of had to... before I had to interrupt him for the commercials, we were just talking about, just all... So everyone, kind of who currently uses Wi-Fi chips, they're not going to have to completely redo how they make products. Like you said, your chipset should integrate pretty seamlessly with what's already out there, just better. And then I believe we were starting to talk about, kind of the folks who have to monitor and, make sure the devices, any rogue devices, like you said, or, pinpoint the interference. They're going to be able to do their thing just as simply as before as well. Correct?
That's right. That's right. Just on a more powerful platform.
Right, perfect. So, and I think this kind of goes with it. So, obviously, if you have 3 different channels, and I think this is what this next part, load balancing, refers to. I'm totally just going to assume, based on the name, 3 different channels. Let's face it, everything would, I guess, by default, just continue to go on a single channel because, hey, this technology has not been widely implemented yet. So, load balancing, this would, this would prevent people from having to go into their device and say, oh, go on to Wi-Fi channel 1 and then you go on to Wi-Fi channel 2, and this would prevent that kind of thing. It does it automatically.
That's right, and where that comes into play is typically in a high density enterprise environment or a stadium or a venue, you'll often get devices that'll all attach to the same channel, but that's simply not an efficient way to get service and to get everybody the optimal performance. So load balancing, it really applies some intelligence to the balancing.
And then power zoning, I believe we touched on this a little bit, but this idea that, hey, you want a single wide-reaching, kind of network, and then you have a more, maybe that's where you have your office workers, and maybe you have like a wide-reaching one, which is just where everyone kind of goes on break, they go outside, they all use their devices. You have your workforce where you need a lot of a lot of very strong signal in that area, and then you have another small area that you don't need as much. Power zoning, I'm assuming I'm describing that in the worst possible way. What is power zoning?
I think you've pretty much nailed it, but it's really about taking those multiple channels that in the spectrum and applying the optimal power to them. Maybe you want the fastest users right up close to the access point. Maybe there's some other users you want to hit that are further away. So you can have a high power channel, low power channel. And in environments where you're deploying more than one access point, it gives you a phenomenal amount of flexibility in deploying the network and really delivering that optimal performance.
I see. So, and I can't believe we're almost 40 minutes into this and I haven't asked yet. Obviously, you're going to have the chipset. I'm sure that you would not be opposed if if any of our past guests have been listening. If you were kind of swooped up and picked up by any of the other previous chip manufacturers out there. But are you making your own products, or are you simply making something for the industry to, kind of use? And by the way, this, I thought that this might lead into a conversation about the, I guess it's pronounced the area, and I believe this is an access point. So what products do you have?
That's right. Well, we go to market in 3 ways. We have a complete line or suite of access point products and reference designs. So very similar to what you'd find from a traditional Wi-Fi vendor with access points and controllers and management. And those access points are typically geared towards the enterprise space. So we count customers like Mediacom as a user of our access points, so the 5th largest cable operator in the U.S. Now, in addition to the access points, we actually develop and sell our own chips. So we sell chips that get used in other people's products. Our Kroger is actually a customer of ours in that space. They're building their own access points for use in their stores. Now, thirdly, and this is really a new line of business for us, is we have a rich patent portfolio at the core of the company. Mm-hmm. And recently we announced a licensing model where we're opening up the ability to use some of our intellectual property and expertise by other chip manufacturers. So some of the big traditional chip manufacturers, if they want to get a jump on Wi-Fi spectrum slicing, we offer a great package for that as well.
Very, very nice. And obviously, I'm sure that you are willing to work with anyone who wants to come up and, kind of integrate with this. Although it does lead to a question, which is when you're doing something like this, every other option on the market, they're selling a different product. And, I'm sure that, you can talk about the difficulty of actually implementing something like this, the cost, whatever whatever differentiates traditional from cutting edge. But I guess my question to you is, how receptive are companies, to what you're producing? Are you growing? Are they very interested in, I guess, this new idea?
So we're seeing a real shift in the market. Since we pivoted the company about 3 years ago to focus on this density theme, it's gone from trying to convince people that there could be a problem with density to density and interference being the biggest problem in the industry. So suddenly we found ourselves at the forefront of this problem that the industry is facing. And what we're seeing over the last year, we've had over 450% growth in revenue last year over the last year. So the uptake is starting to grow. And we're really building a lot of momentum there. So we're seeing a real shift in the industry that's playing quite well in our favor.
I see. And by the way, for everyone watching the video portion, we have we have this your page up, where you show Kroger and the quote, which is very, very nice to see. But you have this graph, and I was wondering, and hopefully you know what I'm referencing to with this graph, where it's the area 2.4 channel and the 5 gigahertz channel, and you say that the 6 channel MCSR mitigates interference. What are you really trying to show with with that graph, if you could kind of lay that out?
So that graph, if I recall the graph correctly, is showing multiple channels operating within the same band. So in-band multi-channel. And that's really the core of what we do with Wi-Fi spectrum slicing and our MCSR products.
Right. So instead of I guess more traditional Wi-Fi would have all 3 of these different channels just lumped into a single channel, and that's what Or
if you attempt to do that, let's say in 2.4 gigahertz, you put in three separate radios. If you're trying to transmit on channel 1 and you try to transmit on channel 11, while you're trying to receive on channel 6, the transmit channels swamp out the receive capabilities. So those are the opportunity, or those times when you can't connect to the Wi-Fi network, or it's painfully slow. That's often what's happening, and that's called adjacent and co-channel interference, and that's where our secret sauce is mitigating the impacts of that.
Very, very cool. And by the way, I see another point here, just as a heads up for everyone else. This Thursday, every third Thursday of the month, I believe, is our All Linux program. We have a Linux expert come on the show, and we talk all things Linux and what's new, what's happening. And really, it's evolved to the point where it's not just a platform to talk about Linux, but it's also a platform to talk about the importance of being open source, and just how open source did so much for the industry and continues to do so much for the industry, and really just large enterprise and organizations are really waking up to the idea that proprietary is great, but open source, I think, gets a lot more innovation out there. So I see here that you have open source, the dual channel Wi-Fi with 2 Linux Open WRT. Why was that so important to make this open source?
Gosh, we're big fans of open source. For us, the co-innovation work that we did with Cable Labs around the emerging dual channel Wi-Fi standard. Now that's a really exciting new standard that allows for the termination of one or more channels on a device, right? Virtually eliminating latency and really helping with those at-home networks. So we developed the OpenWRT code and released that out to the open source community as a way to drive the uptake of the new standard and really drive the demand for our revolutionary spectrum slicing, multi-channel single radio chips.
Very, very nice. And I'm sure that it definitely will, and just the fact that it's open source will, kind of like I said, it will let others, contribute to it, and as they see fit, they will make it work for them all the better. So I really, really definitely do like that. Let's see. So I'm trying to think of any other areas with with this technology that we didn't really touch on. This seems like, way back when, and I think we're up to like Wi-Fi 6 or 7 now with 802.11ax, something that people probably weren't as keenly aware of as they were AC, because AC really ramped up the speeds, and then AX really ramped up the amount of devices that you could have on a single router. But again, your technology, it's complementary to what Wi-Fi 6 is trying to do with its MIMO properties.
That's right. It really gives a way to take Wi-Fi 6, which is single channel, into a multi-channel environment, and creates a platform where the spectrum can actually be sliced up and used more efficiently.
Do you think that when the industry, and you probably know people, more people in the industry than I do, cell phone companies such as Apple or Samsung or any other smartphone company, they'll go out there, and I remember them saying, "Hey, we have this new technology that when you enter a building or you enter a trusted Wi-Fi hotspot, you will automatically transfer from cell data to Wi-Fi, and your phone calls will be handled over Wi-Fi." Did the industry kind of collectively go, whoa, we aren't ready for that? I said way back when that we are expecting so much more from Wi-Fi, and software companies, hardware companies, I think they kind of see Wi-Fi as this thing that's like, we can beat Wi-Fi like a rented mule until the wheels fall off. And I guess it's up to you guys to really, kind of cope with that.
Well, that's right, and what you're really touching on is the seamless handoff between cellular and Wi-Fi, and that's always been one of the holy grails of communication, and it is very, very challenging to do, and most importantly, it's challenging to do without relying on the user to do something.
Yeah.
Like to input a code or fiddle around. The majority of users don't like to do that. So earlier this year, we actually completed an industry first demonstration handing over between cellular and Wi-Fi securely and seamlessly in a live environment. And this was done with at the Wireless Broadband Alliance, along with Comcast and Nokia. Mm-hmm. So the whole momentum around that, the handoff and the seamless nature, that's a foundational piece of 5G. So it's a really exciting demonstration. There's a link to the demonstration on our website, which I urge your listeners to go and check out. It's really shows where the industry is going.
Right. And by the way, everyone, Edgewater Wireless, EDGE Water Wireless .com. We'll have a link to it in the show notes. And by the way, I wanted to hit you with, kind of one more question. You have the ears of, let's say the IT staff for companies. You have the ear of everyone out there who runs their own home Wi-Fi or small medium business. You have all their ears. How do they prepare for this, or how do they start to implement this? What do they look for? Do they look for, hopefully, and this is obviously, kind of looking into the future, are they going to look for maybe some kind of, like packaging detail, or are you putting out your own products? If people are interested in what we've talked about here today and they want this, how long do they wait? How do you foresee them actually getting it into their places of business or homes?
So for the home users, I'd suggest you pick up your phone and call your local cable company or your telco, and you ask them for Wi-Fi spectrum slicing or dual channel Wi-Fi. That really, for us, the way this gets to market is through the large service providers. Now, on the enterprise side, for the IT crew out there, we'd love to hear from them directly. We do have a complete suite of enterprise grade access points that we'd more than happy to get them in front of some of your listeners.
Perfect. Love to hear it. And by the way, Andrew, I want to thank you so much for coming on the show. This could have been a very heady topic, but I think you broke it down very, very nicely. And I want to thank you so much for coming on the show and sharing with us spectrum slicing, what that is, and what you're working on. And this is going to be almost a stupid question, but how excited are you for kind of where you are? Because you mentioned a couple of years ago you were trying to come up with something that was, hey, that's interesting, but now it's wow, it's like we really need something like this. You mentioned that you were at the forefront of this industry-wide problem. How excited are you for I guess kind of the area that you're working in right now?
Oh, this is a phenomenally exciting time for wireless, and we're right at the forefront of where the industry is going. It couldn't be happier of where we are and where we're headed. It's great time to be here.
Absolutely, and once again, edgewaterwireless.com. We'll include a link in the show notes. Andrew, any last words? Anything that we didn't talk about? Anything that we didn't touch on?
I think you've pretty much covered everything. So Wi-Fi spectrum slicing and Edgewater Wireless.
Perfect. And everyone, once again, show notes, computeramerica.com, and be sure to check out the website. Andrew, until next time, I'm really, Computer America is hoping to, obviously we're out there at CES and the like, but hopefully next year and in the coming years, we're going to get to more industry specific, kind of conventions. So, hey, hopefully we'll actually be able to meet each other face to face. And I'm looking forward to seeing what you guys, come up with in the future. Thank you so much for being on Computer America.
Thank you for having me.
Our pleasure, our pleasure. So until next time, have a great one. Bye-bye. All right, everyone. So there we go. And let's go ahead and choose this button right here. We're trying some new technology here in the background, and that was a lot of fun. By the way, you may have noticed that the audio was really great. And by the way, I want to thank, I actually want to thank Nelson out there for, I guess, turning us back on to Zoom meeting, things like that. It's nothing against Google Hangouts, nothing against Skype, but Zoom really has a very interesting product, and it worked very, very well. So I'm happy with how that worked out. Once again, if you want to find out any information, or if you want to check it out for yourself, check out Computer America after the show. We should have everything up there by the time you go and check it out. Now, everyone, we have a couple more minutes left. Let's go ahead and continue on. Computer and technology news brought to you by Computer America. Here we go. So everyone, hey, I hope that you're doing well. And once again, welcome back into the Computer America show, because we were off, we were on the air, but we were running repeats all last week. So we took care of everything that we needed to. Full week of shows here at Computer America this week, and we couldn't be happier about it. Let's go ahead and talk about this story. So this one, obviously, it's boy, is this a pipe dream, but I hope that it works. So let's go ahead and talk about this. Tesla, you know the one. Tesla may soon have a battery that can last 1,000,000 miles. Yes, that's 1,000,000 with 7 zeros. Very, very interesting. So let's go ahead and talk about this here. Saying that Elon Musk promised Tesla would soon have a 1,000,000-mile battery, more than double what drivers can expect today. A new paper suggests that he wasn't exaggerating. And I think what they're saying here, just before we get anyone too excited, obviously a 1,000,000-mile battery, not a single charge 1,000,000 miles, but rather a 1,000,000 miles on a battery that, well, won't degrade over time, or won't degrade as fast as it currently does. So last April, Elon Musk promised Tesla would soon be able to power its electric cars for more than 1,000,000 miles over the course of their lifespan. That's the key takeaway here. Don't think that we're about to hit some kind of weird battery, warp speed, quantum leap kind of advancement. At the time, the claim seemed a bit much. That's more than double the mileage that Tesla owners can expect of their current battery packs, which are already well beyond the operational range of most other electric vehicle batteries. It just doesn't seem real, except, well, it appears that it is. And if you're wondering who's doing this, it's a university group, and they have published a paper in the Journal of the Electrochemical Society, describing a lithium-ion battery that should be able to power an electric vehicle for over 1,000,000 miles while losing less than 10% of its capacity during its lifetime. Ladies and gentlemen, if you have ever used a smartphone, for longer than, and this is going to seem so weird, for longer than 2 or 3 years, you'll notice the battery life of your phone just doesn't hold up. It doesn't hold as much of a charge. It goes dead faster. And that's just for a phone. That's just for checking your email. Think about a car that has to carry things. It's going to have an uneven load. It's going to be put under extreme stress. This is very, very impressive for what they're doing with batteries. So they mentioned that physicist Jeff Dan, he's one of the world's foremost lithium-ion researchers. He mentioned in the group that they showed its battery significantly outperforms any similar lithium-ion battery previously reported. They noted that their battery could especially be useful for self-driving robotaxis and long-haul electric trucks, 2 products Tesla is developing. And I guess why they're saying that in particular is because those are vehicles that, when you think about it, an individual car, like a car that an individual will own, if you're really, really driving, you could do like 200,000 or 300,000 miles on a car over the course of the car's lifetime. And, if you're really, extreme edge cases do apply. There are individuals who will drive, 1,000,000 miles and things like that, but those are few and far between. The current lithium-ion battery life for most drivers is going to be sufficient. 500,000 before you need to replace the battery. That's pretty good. They are specifically targeting industries that, with a robotaxi or a long-haul electric truck, those are 2 industries that you will be driving 1,000,000 miles potentially a year. Or at least over the course of 2 or 3 years, you'll be driving that many miles. So that's where it really comes in handy. One more part of these vehicles is just going to be that much more efficient and potentially cheaper, potentially bringing them to market even faster. So they said that the full details of these cells, including electrocomposition, electroloading, electrolyte composition, additives, essentially has been provided. This has been done so that others can recreate these cells and use them as benchmarks for their own R&D efforts. So essentially what they're saying there is that, and by the way, that was the lead researcher and chemist physicists. They're saying that, hey, you can't steal our battery, but if you want to recreate it yourself and then compare your own efforts, you can potentially leapfrog us or, kind of see how we do it, and then you can do something even better if you're able to. So that's great. Obviously, within the EV or electric vehicle market, battery chemistries are a closely guarded secret. So they mentioned that, hey, they signed an exclusive deal with Tesla in 2016. They released their paper, they released their composition, and now anyone out there, they can't steal it, because if they're found to be using the same battery composition, then, hey, that is stealing. They received a patent for it, but if anyone out there wants to create it, they're essentially saying, we have a really good product. Try to do better. So it's actually very interesting. So the article goes on for a bit. Wired did a really good job researching this, and I'm sure that a lot of people, would be very fascinated with reading the entire article. We're not going to be able to. We're actually coming up to the end of the show here, but the article, ends by saying that whatever designs ends up making it into the production of Tesla's massive gigafactory, the signs are clear. A 1,000,000-mile battery will be here soon. And if nothing else, this just cuts waste and pollution of these batteries, because obviously you would have to recycle them or things like that. You would have to, the single move cuts waste and pollution in half because they can last twice as long. This is definitely a very interesting article, very interesting idea, and I really hope it to be true, because this has implications, as we've said so often here on the program. Whatever boost to battery performance you have, that helps everyone and anything. Batteries are one of the biggest chokeholds that we have here on the industry, in so many industries. If we can improve that, we're going to be much better off for it. Just like improving Wi-Fi. Everyone, thank you for tuning in to today's program. A lot of fun. Please, if you would like to follow us on social media, please do that. Find us wherever podcasts are heard. In the meantime, everyone, tune in tomorrow. More Computer America. Hey, thank you so much for tuning in. Have a good one. Bye-bye.